So, as already stated, I would like to talk today in this discussion a bit about open LiDAR datasets and how you can access them. But before we dive deep into the topic of data repository, I would just like to highlight some challenges you are facing when working with LiDAR datasets. Um, so first challenge might be the complex processing. So when you start a project, you have to ask yourself, will you be able to do the LiDAR processing job up to the project requirements in time and on budget? And these two things quite a lot of times do intertwine between each other. Then the next challenge is the infrastructure. So with rising point densities and data sizes, you have to ask yourself if you have enough data storage, if you have enough compute, do you also have all the right tools to do the job? And with all AI hype, should you also adapt AI in the processing? And then last challenge, which will also be the focus point of today's presentation, is finding data sets. In case you are not acquiring your own data and like to find some LiDAR data sets, the first question you have to ask yourself, is there any available data for your area of interest? And then the next thing is, how can I download it? How can I access it? After that, also there is a licensing. So different organizations do license data sets under different licenses, and you have to pay attention what is the license. So why are all those challenges happening? So there are different drivers from pull, push side that are playing here. So one is that as industry for LiDAR is maturing, we are getting higher and higher expectations in projects. So we are requested to deliver greater classification accuracies. More categories are being requested. So if, let's say, 10 years ago, we mostly had to do classification of ground points, buildings, and vegetation, now all sorts of objects have to be delivered, such as fences, towers, wires, roof objects, facades, etc. And this makes projects quite more complex. And then the third thing is also shorter deadlines. So in nationwide LiDAR scanning projects, it happens a lot of time that it takes more than a year from the day that the data was acquired to the day that it is officially and publicly available. So from the user point of view, or end user point of view, it makes much sense to shorten those deadlines, but this then brings another challenges in the process. The second thing is, which I already mentioned, that the volume of the data is increasing. So this is mainly due to or higher or newer, better sensors being manufactured that operate at higher frequencies. Some are even multi-headed. So we are generating larger point densities. Also from the project requirement side, there is a requirement for higher point densities. Then it's a good thing for end use cases is that we have more frequency. So a lot of times we already see like cyclic projects that repeat every, let's say, 3 years, the cycle of LiDAR scan of the entire nation. And then also our new use cases which require higher point densities. Also, there is a push driver bringing some of the challenges in, which is mainly new tools, AI, should we adopt it, how to stay ahead. And those new tools also are enabling new use cases. And last but not least is the fragmented open LiDAR dataset access. So currently in Europe, more or less each country has its own portal for accessing the LiDAR dataset. In some countries, even each region has its own portal. Then sometimes you are not even able to download the data through the web. So we have cases where we actually had to ship hard drives via regular post to get the data set for particular countries. And this, when you're trying to just deliver a project, it's quite frustrating waiting to just search for the data, then wait for, I don't know, 1 month to get the data back from the post which was shipped through the regular mail. So we at our company faced this problem many times. So therefore, we decided to try to create a single repository for open LiDAR data set. So we begin on this journey around last year. We started adding mainly data sets in Europe. So currently, think around 2.8 million square kilometers of LiDAR data sets, which is around 23 trillion points, covering 16 countries, mainly in Europe and also some regions in States. Altogether, there are 113 unique data sets as today, and this is around 250 terabytes of LiDAR data and 3.2 million objects, so meaning individual files stored in object storage. And this list is growing each day, so we are constantly adding new data sets. So for the full list, you can go either to our hub.fli.ai or to GitHub, which is linked below, where management of all the data set is managed through. So how you can access this data in the repository? So there are 3 ways. One is our Open LiDAR Data Hub, which is at address already mentioned. Second one is our QGIS plugin. Actually, the feature is coming soon. And the third way is directly through AWS with the AWS command line interface. And yeah, now we'll take a look at each individual option for accessing to see, so you can see how does it work. So first, let's look at our OpenLiDAR. So here you can just click on the data set, the map. On the right-hand side, the viewer is displayed. Then the second option is that you can just type the name of the city, street, or whatever, and it will zoom in and display the data set for that region. Obviously, it has to be available there. And then third option is just to search this area, which creates the bounding box around the current viewport. Also, on the left-hand side, there is a table. So if there are multiple data acquisitions for that region of interest, there will be a list of all data acquisitions available. So next thing is the viewer. So I already briefly mentioned. So it's simple pottery viewer. You can do some cross sections, some basic measurements, or also change attributes like intensity or classification. And you can also do filtering based on the classification. Then the next thing is downloading the data. So you can just press download button and will create a clipped data set around the clip you created. And second thing is that we also offer pre-trained classifiers and other point cloud processing tools directly in the application, so that you have like large batch job for larger area. You can execute it through the web application, and we will process it behind the scenes. So the second option, which is actually coming soon, is QGIS plugin. So our QGIS plugin actually will have or have 2 features. One is that is user interface for our command line interface, because apart from Open LiDAR dataset, we are also as a company delivering command line interface for our pre-trained model for point cloud classification. And some users prefer graphical interface compared to command line interface. Who would thought that? But yeah, the second thing we're adding here is also, and also today in the morning QGIS feature frenzy talk, I heard about a super feature of cloud. in QGIS. So you just put in the URL for our open LiDAR repository. It is open access, so you don't need any credentials, and you can then browse through all the files directly in QGIS that are stored in our repository. So then the third way is just to browse. Oh, I hope you can see something. So the third way is that you can just browse on AWS S3, use AWS command line, so you can just list through the folders. I will go a bit in more details about the folder structure in a few slides, but yeah, you can just list when you find the data set that you are interested in. You can just copy it or copy the entire folder or single file or whatever it makes sense. And once the data is downloaded, you can simply open it in your favorite point cloud viewer. Right. So that brings me to a bit of behind the scenes. So to host data, we had to do some pre-processing. So I would like to just talk a bit about the um, processing pipeline. So first thing is we have to retrieve the data from the mapping authority who owns the data. As already said, sometimes this is via regular post on the hard drives. Sometimes it's through the FTP. Sometimes it's just scraping them. So once we have the data, we generate bounding box geometries around each individual file. Sometimes this data is already available, so we can just convert it to our predefined schema. The second thing is to convert it to cloud optimized point cloud, COPC, HOP, or however, how is it pronounced? If anybody knows what's the correct term, COPC. So conversion in COPC, for those who don't know, it creates like a octree structure in regular LAS file. So you can view it through the viewers like Pottery and also QGIS actually to support viewing of point clouds, converts it in the COPC format behind the scenes. And last thing is that we also generate like an overview file for the entire data set. This is kind of a hackish way to represent entire countrywide visualization of the whole data set. Once you have all those steps completed, we have to copy the data to the object storage, in our case, AWS S3. Then create merge requests on GitHub. As we also import all those records in our database. And with that, the data is published and everybody can access it. So a bit about the folder structure on our data repository. So link to the repository is okay, S3 protocol, then open minus LiDAR minus data. Then all data sets are in subfolder data. Then the number of subfolder is country, so ISO code for each individual country. We will see what will happen when we will get to the multi-country data sets, but yeah. So next level of folder is the organization or the authority that is actual owner or producer of the data. And then, because we have multiple, let's say, acquisitions each year, we have then project or scanning name folders. And now we are at the last, let's say, layer of folder structure. So first we have COPC folder, where actual all point clouds converted to COPCR. Then we have overview folder. Then it's a shape folder. So probably we will move to GeoPackage soon, but currently it's shape. Then we also have license folder where there is a PDF with the license, and also original LAS or LAS files. Although for some projects we did delete those for cost saving reasons. Uh, so maybe interesting also. So we are using AWS. We have enabled smart steering to do some cost optimization, and we have frequently accessed files, infrequently accessed files, and archived files where frequently accessed files are all that have been accessed in last 30 days, then infrequently are between 30 and 19 days, and archived are after 90 days. So just roughly about 10% of our data repository is always in frequently accessed storage. Another 10% is in this infrequently accessed, and then all the other is in archive mode. Although even if they're in archived, AWS guarantees like millisecond access also to those archived files, so this should not be a problem. Then maybe a bit about costs. So first thing was converting all this data in COPC, generating indexes, overviews, transfers. So if we would pay for EC2 instances for all those pre-processing, it would cost us around 20k euros for those 2.8 million square kilometers. Although we applied some cloud credits, etc., that covered that spend. Also, it could be optimized a bit further. And then the second thing is the cost of storage. Just to store this data, it costs roughly US dollars per month, around 63, 36, oh, 36,000 USD per year. We applied for AWS Open Data sponsorship, so actually AWS paying for that cost, because if we would be paying for that cost out of pocket, I think I wouldn't be giving this presentation here today. So that brings me to open data and business. I guess this is also for another time, but we are still asking ourselves how to make data, how to make money with free data. And, spoiler alert, we don't know yet how to monetize that. I hope I will have talk next year on FOSS4GE and have a bit on this slide. So yeah, that brings me to my last slide. So we try to build this open data repository, and if you would like to contribute to it, add datasets from your country, you are more welcome to contribute. You can go to the GitHub page, open an issue on a GitHub page, and then we can discuss how to add your own data from your organization or your country, or data of your interest that you would like that is published here. So with that, I'd like my presentation, and I think we have, right on time.